Today's lesson will cover one of our topic 1 vocab words and section 1.1 on equivalent ratios. So our first vocab word is equivalent ratios, which are ratios that represent the same relationship between two values. For example, if we have 2/3, it is equivalent to 4/6 because we have multiplied the numerator by 2 and the denominator by 2. Therefore, 2/3 and 4/6 are the same value, even though they look different because there are different numbers in the numerator and denominator. A non-example would be 2/3 and 2/9. These are not equivalent or not equal because the numerator has been multiplied by 1, but the denominator has been multiplied by 3. So the value is not the same because they have not been multiplied by the same number. A visual representation of this, we have 2 out of 3 pieces right here. The right side is the same until I would like you to draw a line that cuts everything in half. So now we have 1, 2, 3, 4 pieces out of 6. So this is a visual representation of 2/3 being equal to 4/6 because we have the same amount. You see these blue squares are the same amount. They've just been cut into more pieces. So we have the same amount. It's just a different number of pieces. This is how I would like you to add your vocab to your notebook. You would fold the vocab sheet over, write the vocab words on it. We'll be covering unit rate next week. So this goes on page 6 of your notebook. Just to highlight some of the reasons we learn ratios, they're used in a lot of things. You have survey results, you have party planning, media coverage, calculating unit rates to find the best prices. You'll notice here, this is a picture of a TV versus film aspect ratio. You have a widescreen TV versus a standard TV, and there's lots of different ways. So this is on the top of your note sheet. I'd like you to fill in, there are 16 girls and 13 boys in a class, and try to think of the 3 different ways we represent ratios. One of the ways is using the word 2. So the ratio of girls to boys is 16 to 13. We could also use a colon. We would say this is 16 to 13, except for we say 2, but we use a colon. And we can represent it also using a fraction, 16 to 13. The order does matter. Girls have to be listed before boys. So 16 to 13, 16 to 13, and 16 to 13. Okay, so here's a picture for the next example on the note sheet. We already did the top part here. Now we're on example 1. So please fill in USC score is 20 and UCLA score being 38. So we want to write UCLA score to USC score. So the order matters. So we need to have 38. Okay, and I'm adding in here as fractions. So we're going to have 38 over 20. If you put 20 over 38, you've given USC score to UCLA score. So make sure the order is accurate. For part B, we're doing USC score to the total points scored. So total points scored would be 20 plus 38. And that would give us 58. So we have a ratio of 20 to 58. And then the total points scored to UCLA score would be 58 to 38. So here's a situation that's not on the notes, but just to think about. If we're told the 49ers played the Cowboys and the ratio of the 49ers score to the total points scored by both teams is 21 to 27, what do we know? So someone who wasn't paying attention would say, oh, this is the 49ers score, therefore they lost against the Cowboys. However, this told us it's the total points scored. So therefore, if the 49ers scored 21, and this is the total, 27 minus 21 would be 6. So the Cowboys only scored 6 points. So the 49ers won by quite a bit. That's what this ratio would tell us. So using a very popular example of a pizza, we have 1/2, 1 out of 2 pieces. And then if we cut this in half again, we now have 2 out of 4 pieces. But the amount of pizza we have is the same. It's just been cut into more pieces. That's what an equivalent ratio is, or equivalent fraction. So these are on your note sheet. Please highlight the rectangles on the right of each one. So on this one, we have 1/2. Over here, I'd like you to draw in 2 lines that will make this 3 equal pieces, and then 2 lines, 3 more equal pieces. So now we have 1, 2, 3 out of 6. What we've done is we've added, and we've cut these into 3 equal pieces. So we've multiplied by 3, and we've multiplied each of these by 3. And so we get 3, 6. Here we start off with 4 out of 5 pieces. So please highlight 4 out of 5 pieces. And then I would like you to cut each of these into 4 pieces. You could draw 1 line across the middle and then 1 line down the center of each of these. So we've cut them into 4 additional pieces each. So we're multiplying the numerator and denominator by 4, and therefore we have 16 out of a total of 20 pieces. Okay, if you open up your notes, you're going to have some pre-written notes in here, and then you're going to do a U-try. So to use prime factorization, you would want to make factor trees. So you're going to find two numbers that multiply to 24. I did 6 and 4. You could do 8 and 3, 12 and 2. There's a number of possibilities. But if you use 6 and 4, then you need to keep going because they're not prime. So 2 and 3, those are prime, so we can stop. And then we have 2 times 2 being 4, so we can stop. Now we're going to do prime factorization of 40. I did 4 times 10. Then you keep going until you only have prime numbers. So what's happened over here is we have 2 times 3 times 2 times 2. That is representing the 24. And then the 40 is equal to prime numbers of 2 times 2 times 2 times 5. Now, if we cancel out any number divided by itself, okay, so here we'd cancel out these 2's. We could draw a line through it. That's what we do in class. And then here, these 2's would cancel out because 2 divided by 2 is just 1. And then we also have a 2 here and a 2 here. So these 2's could also cancel out. 2 divided by 2 is 1, and we're left with 3 over 5. So the simplest form, equivalent fraction in simplest form, is 3/5. So the one I would like you to try is 36 over 54. You could pause the video and try it, and then check how you did. So if you do factor trees of this one, which I don't have here because in class we write them in, 36, you could do 6 times 6. Unfortunately, I'm not able to write it on here because it's on PowerPoint, which would then become 2 2's and 2 3's. And then 54, you could do 9 times 6, and 6 would become 2 times 3, and 9 would become 3 times 3. So on top, you'd have 2 times 3 times 2 times 3. And on the bottom, you would have 3 times 3 times 2 times 3. So 2 3's will cancel out, 2 2's will cancel out, 2 3's will cancel out. So sorry that I don't have the visual here, but the answer is 2 over 3, 2/3. So the answer to this U-try is 2/3. Now, method 2 is divide by a common factor, but not the GCF because we're going to do GCF on the bottom. So here, a common factor is 4. 24 divided by 4 is 6. 40 divided by 4 is 10. Now, we have to keep going because this is not in simplest form because they still can be divided by 2. And after you divide by 2, you're going to get 3/5. The U-try is 44 over 66. So if you do a common factor of 2 on this one, 44 divided by 2 is 22. 66 divided by 2 is 33. 33. I said that correctly. And then 22 and 33 can still be divided by 11. And so the answer to this one is 2/3. So if we do 24 over 40 factoring by GCF, we would split this up into 8 times 3 because the GCF is the greatest common factor, and the greatest common factor of both of these is an 8. So if you have 8 over 8, you would cancel the 8's out, and you're left with 3/5. The U-try for this one would be 30 over 42. So you have to think about what's the GCF of 30 and 42. Well, the GCF of 30 and 42 would be 6. 30 divided by 6 is 5, and 42 divided by 6 is 7. So you'll get 5/7 for this one. And I apologize, I don't have it here. It's because in class we write it on the smartboard, and therefore my PowerPoint is not showing it. Here, dividing by GCF is similar to the last method. You're just saying divide by 8, and you'll get 3/5. So I'd like you to try 15 over 60 using the GCF, if you can figure out what the GCF is. The greatest common factor of 15 and 60 is 15. So if you divide by 15 to both of those, you're going to get 1/4. Okay, we're back to the front bottom part of the notes page. Find ratios equivalent to each with lesser terms and greater terms. So this one, I'd like you to write in an 8. So we have 4/8. So that's the visual. You do not have to write that on your notes. Now, lesser terms means we're simplifying it and making it these smaller numbers. Simplifying means reducing the numbers. So 4/8 is equal to 2 times 2, and 8 is equal to 2 times 4. So you could cancel out the 2's and you would get 2/4 left over. You could also divide to get lesser terms and you'll get 2/4. So that's one of the examples. The other option, okay, and there's the visual. So when you take away the lines by dividing by 2, so you're taking away how many pieces it was cut into, you make the pieces bigger. The other option would be the simplest form of this one, which would be the GCF, so getting rid of the 4 here or dividing by 4, which is the same thing, and you get a half. So you don't have to have both of these, but lesser terms means you've divided lesser terms, and it does not say simplest form. So in this case, either of these are okay. Then we'd have to do greater terms, part B. So we're on part B now, greater terms. So that means we're making the numbers larger. So we're going to cut this into more pieces. So if I do times 2 to the numerator and the denominator, one example of greater terms is 8/16, and that would be drawing a line here visually. So now we have 16 pieces, and therefore 8 are shaded in. You could also multiply by 10 and get 40 out of 80, and you could really multiply by any number. As long as you do the same number to the numerator and the denominator, it will be accurate.